All right. Hello, my name is Jason Beneteau. I'm IoT architect for MAGNA. Just a couple brief slides here for those of you who are unfamiliar with MAGNA. We classify ourselves as a digital mobility and technology company. We have about 340 plus or minus manufacturing plants globally, about 160,000 employees, and actually in North America, we are the number one automotive supplier, and globally, we are number four. Dig in a little bit deeper because as this presentation goes along, I'm going to dig into a specific use case and having some background behind MAGNA and how we set things up. We're a little bit unique in some areas that change the way that we made some decisions. And it's something to think about, though, of how you roll out your digital transformation. And so within MAGNA, we're very, we're very diversified, where we make pretty much every part of a car, including the whole vehicle itself. So specifically, I work more in the body and chassis group. But we also make exteriors, roofs, powertrain, electronics. I'm getting very heavy in electrification currently. But across all these different product systems that we have, we give each of our plants and each of those different groups a lot of autonomy in how they want to run their business and what equipment and applications that they choose to run in those specific plants. And so when we come to digital transformation, it becomes interesting because we don't really have two plants out of the 340 that use the same software or equipment. But from a corporate perspective, we like to have at least some minimum requirements or standardization of how do we take all of this different, equipment and applications, but build this unified system that actually makes sense, for the plant itself and for the corporation as a whole, when we want to do, roll-ups and various other calculations, across each product group. And so that's where, open architecture really comes into play here, because trying to pick a proprietary platform to try to tie everything together really doesn't work. We look at it as more or less, Lego bricks, as I like to phrase it specifically, where you can take all these different Lego bricks, you can pull one out, you can plug another one in. And so with open architecture, the big concept here is, you can add, upgrade, modify, swap all the different components without too much headache, and where you can use the tools in that specific component that does that job the best. You're not relegated to trying to use this platform that does 50 different things, but 40 of them it does mediocre and only 10 of them really good. Like, we're trying to optimize, continuous improvement, where we want all 50 of those components to be the best of breed and not sacrifice along the way just because we're trying to pick just one software or equipment platform. And so this digs in, deeper of why do we really need this open architecture? And when it comes to digital transformation, the number one issue we have is siloed information. And how do we eliminate those silos? There's databases here, spreadsheets there, files everywhere. And how do we get the data and the information, like, Chris presented, how do we get this information to the people that need it when they need it? And how do we efficiently and effectively do that? Barriers to entry, it is tied to the siloed information, but also sort of, ties back into that previous presentation also, where when I'm designing an architecture, not only can I think about how do we make this, easy to implement? I think that's probably, a common one that most people are thinking about. But also long-term maintenance, because even once we implement this, how does that plant, take the baton and run with it for the long term and not just fall on their face, and have no idea, what to do, or let's say if they, if it's extra cost for licensing or anything else that, they really didn't know up front. Like, we have to be very clear and concise, what the long-term plan is and for how they're going to use it, and, how they even expand and scale from that point. And, big reason why I'm here today, proven technology from other industries. I know there's not a lot of other manufacturers here today, but it's very important for us to look outside of our automotive industry and what are the best practices being used in other industries. And I hope you can take some, points away when we get into the details here for our applications. You really have to keep your eyes open, because the technology is not very different when you look at it at the abstract. We all want to use cloud, we all, trying to use the latest and greatest high tech, whether it's on the OT side or the IT side, and it's really the same building blocks. There's not that much difference. And then the following points are talent pools. And, as we move towards, whether you want to call it digital transformation or Industry 4.0, it becomes very apparent that we need to make sure that when we open up a position, there's actually that talent pool out there that of someone that we can bring in. And, I think across all industries, that's an issue right now, but we have to think a little bit more abstractly about what we're designing when we get into that. And I have a slide, a couple down, to dig into the details. Sort of the anti-ISO 95 typical slide here where we got a circle going, but this is just a data model. This is not a networking model or, a physical implementation model here. But the point I'm trying to make, with open architectures, is that we need to open up the pipeline of how we move data from point A to point B. Generically, I like to just call them endpoints. I don't care if it's a robot or your ERP system. It doesn't matter to me. It's an endpoint. And we need to think about how we can actually standardize on a communication protocol to move that data, between any two endpoints. And what we found, because in MAGNA, we standardize on MQTT as our preferred data pipeline protocol. And whether we're designing the software in-house or we're buying off-the-shelf software, doesn't really matter, that we found our implementation time when we're integrating into this architecture, that we're able to reduce the implementation time by about 30 to 50%, that we are wasting so much time previously just trying to figure out how do I convert this type of PLC and get that data, into, this new AI application, or where it's, very complex data types. It's just not simple Boolean or tags or integers or something like that. Today's applications are a lot more complex, where a lot of the systems of past that relied, especially in manufacturing, relied on tags or tag-based systems, that when we are building out our next generation systems, those models don't really work. And so having a pipeline that can handle any type of data that we want to flow through there was a very important decision for us to standardize on. And that's where we have our convergence of OT and IT also, is there's no longer the OT protocols that those guys use for when they want to put data on the pipeline or pull data off, or from the IT side also. Everyone's speaking the same protocol, and it doesn't matter, what you're doing. That's the central pipeline where you put your data. Taking a step back and looking at a higher level of security, we found that we were pretty much incapable of securing all of the different protocols that we were using previously, and being able to standardize and get really good at one protocol that everyone is using. You can actually develop the proper security standards, because previously, if we're using one, or I don't want to say one protocol, typically we're using 20 different protocols on the factory floor, and 10 more different protocols, up in the front office. How do we effectively secure those? We may be able to secure certain aspects of them, but even from, user authentication, the auditing of who's logging in and what they're doing, read access, write access to certain things, the access control behind all of it. Yes, like for some of them we were able to, but at a high level, having that kind of protocol sprawl is a very serious issue when it comes to security. And so being able to take a step back and say, we're not going to be transferring data around the plant and outside of the plant and all these different protocols, we're just going to focus on this one. We're able to really dive deep in to come up with the best practices that everybody understands of this is how it's secured, and we can meet those best practices. Then finally, democratization of data. As the point I made previously of getting data to the person that needs it when they need it, obviously with proper authorization, going back to the security piece. But for digital transformation, we need to empower our employees to have that data. And even if they have a hypothesis, have that idea of, if only I can look at, let's say, these 3 machines and I can associate this quality problem that's going on with this other gauge, and how do I tie this all together? By making a central pipeline of how you actually put those pieces together, you can start to democratize your data, and it's no longer, they don't have to, go to 20 different people to ask for all their data and have someone tell them no or anything else. We need to get the data to the people. And sort of tying into this too, I like to call this my anti-unicorn pitch, is we found, especially in my group, where before we started to focus on open architectures, and I think we went down the path of most manufacturers, especially automotive manufacturers, but I think a lot of manufacturers in general, of where we wanted to, pick some platforms that we use in our industry, some quote unquote automotive or just, manufacturing platforms, for whatever that means. But that's how, a lot of these are marketed, where when we go to hire someone now to actually start to implement that, or we want to build out our team, or even just, if we have to backfill any employees, that when you pick very niche type applications to base your whole architecture on, this is what this is about too, it's the backbone of your architecture. You can have going back to the Lego bricks, you can have a Lego brick, that's proprietary, where it's a secret sauce of some company that you're licensing, that Lego brick from. That's great. I'm an advocate of that. But it's when you build out your whole core architecture on the fact of this proprietary platform is where the alarm bells in my mind start going off. Is now hiring someone, it's your candidate pool we found, and even some of the more popular program or applications might be in the thousands to tens of thousands sort of range in North America. And in some of our other places, I mean, we're a global company. We have, China, India, Europe, Brazil, where, if we have to hire someone in Brazil, like, are they going to know this platform? No one in Brazil may even have heard of this before. Where by looking at open architectures, open protocols, and all the like, that we found that we're actually able to increase our candidate pools of not only, more global, but also take that. There might only be 10,000 people in the world that know how to do this right now, but we can switch that to 10 million people in the world, and they may not even be in manufacturing. They may have learned that from high tech, in California, or, off in some other remote corner of the world where they're in a completely different industry, or even just as a hobby that they were using, those applications and those protocols and those architectures to do other things, that we can, bring those in and rope them in and give them the training for our specific pieces, but at a high level, increase that out. Then also too, this is a big one for us in our IT and OT convergence for digital transformation, is cross-functional teams. So typically, we have IT, we have OT. And when we're all speaking one protocol, it makes it a whole lot easier for them to even understand each other and the inputs and outputs from each of their pieces, and what they need to do and how they need to provide. So building out those cross-functional teams, they have a lot better understanding of what's going on. So this application here is actually a really cool application using augmented reality, but I'm going to actually skip over the whole augmented reality piece. But, come up to me afterwards and, we can talk about this. But the basic premise of this application is we're doing quality inspections of our parts. So you can imagine, we're an automotive supplier. We got parts coming down the line, and we need to do quality inspections on these parts. And so, this is a real life production system we use globally. The plants have an option for augmented reality. They can use a tablet version or a wearables version, like a HoloLens or Wear. Doesn't really matter there. But what was interesting is when we originally designed our proof of concept for this application, we partnered up with a company and used their proprietary, I'll call it API servers and sort of backend system that's very specific to our industry. And what we found out was just the limits it puts on us. You could see how many times I put limited on there. And basically it was just holding us down of what the actual possibility for what technology was out there. Just because we're limited to what we were told we could do in automotive, but we didn't want to do what was typical for automotive. We wanted to act like a high-tech company and do what high-tech companies do. And so that's where we broke out of there. We actually redesigned the whole back-end system using an open architecture to where we were able to scale out to 65 plants in 3 months. And to be honest, 2.5 months was just training the people. It actually only took 2 weeks from the technical side to roll out this whole augmented reality application for quality inspections. And so, but the only reason we were able to efficiently and effectively do that is just using standard tools. So obviously, we use the cloud, but we're able to spin up the back-end servers, for our applications in minutes. Is literally 2 clicks of the mouse. Now our code is, now copied, running in North America. It's now running in Brazil. Click again. Now it's running in Europe. Click again. Now it's running in Hong Kong. And so, the ability to do that using a lot of the tools of, yesteryear just wasn't possible. But you have to look at, again, what other industries are doing and try to cherry pick best practices. Something sort of interesting too is, SQL Server and our blob storage, every one of those divisions has their own instance of those. So this application also, is running 65 different databases, 65 different storage accounts for all the pictures that are taken during that. And again, to roll that out was just a few clicks of the mouse, and to roll it out at that kind of scale in manufacturing isn't very typical. And now focusing down on the bottom right-hand corner of this slide, I call this our Industry 4.0 data path. So this is very similar to a couple slides ago when I was talking about MQTT, is we realized that, we don't want to silo this information. These quality records that we're generating out of this application, we don't want to just silo them in the traditional application design where we're just sending them in some database off in the cloud somewhere. We have all of these on-prem systems that need to know this information in real time as it's happening. And so that's where we're also sending the records through our event streaming systems. And then, within each plant, they're all a little bit different, like I mentioned, but generally speaking, their MES systems and their manufacturing lines are all subscribed to this data in real time, and instantly out of this application, they're able to get that quality inspection record. And, if something's wrong with the part, we're able to, pause the line, fix what's going wrong instantly. If this part ends up being, scrap material, we can lock it out that serial number of that part is not allowed to be shipped to the customer. And trying to do this level of integration between all of this diverse set of, let's say, MES systems that we run across our facilities previously just wasn't really possible with, closed off proprietary systems. And so, having an open architecture was very key to make this work. So just to wrap it up here, so, key takeaways, ideas to cash. And how do we implement faster? That's one thing pretty much, all of us want for digital transformation is how can we, have this hypothesis, gather our data, turn that information, and put it in production faster. How do we scale? How do we increase our functionality? That's my number one pet peeve of when my tool is my limiting factor and not just that thing hasn't been invented yet. Decrease our tribal knowledge. How do we increase our, our candidate pools, our talent pools, so that way we can actually, efficiently and effectively hire people to implement this thing and not just get stuck in, well, this is the way that we've always done it. These are the tools that we've always done it with. Look outside the box and, use technologies from other industries. I can't stress that enough. Of really look at other industries, seeing what they're doing, and, implement those best practices that you learned. All right. Thank you.